Good morning students, I am Dr. Anand Babu Kancharla. Today I want to discuss about B.Tech subject, measuring instruments, types, effects, essentials, PMMC and moving iron instruments. Those topics today we will discuss here. So first of all, coming to introduction, what is the measuring instruments? Measuring instruments, those are used to measure the electrical quantities such as voltage, current, power, resistance, etc. Those instruments are called measuring instruments. Okay, these type of instruments are used in laboratories, industries and power system, wherever. It must be measuring instruments are need to use. So coming to classification of measuring instruments, generally those instruments are classified into absolutely instruments and secondary instruments. Okay. In secondary instrument again classified into indicating instruments, recording instruments, integrating instruments. So again these types are classified again into analog instruments, digital instruments. Coming to absolutely and secondary instruments, absolutely instruments measures quantity in terms of physical constants, which give the reading by physical quantities. Example, tangent galvanometer. Secondary instruments require calibration with the standard instruments. So example, ammeter, voltmeter. Those instruments have to pre-prepared scale, the pointer moves on a scale. This type of instruments is called secondary instruments. So many effects it will be need to control the measuring instruments. Essential requirements of measuring instrument means deflection torque, controlling torque, damping torque. Torque is nothing but a twisting moment of a force is called torque. Those torque is required to operate and measuring instruments, because these torque, without these torques the instrument did not give the reading. So first of all, deflection torque. Deflection torque means the torque required to move the pointer from zero position to final position on calibrated scale, which is based on different types of effects it will be used. Those effects are thermal effects, induction effects, magnetic effects, chemical effects. Based on that effects, it will be operates. So deflection torque give the reading from zero to final position. Based on the supply, when the pointer moves, when we are giving the supply, the pointer moves from zero position to final position. Controlling torque. Controlling torque means the pointer at final position, it should be stopped at final some x position. So to stop that pointer, we need to give the controlling torque. The torque required to stop the pointer at final position is called controlling torque. The controlling torque is given by two types, spring control and gravity control. So two spiral hair springs are used in spring control. Gravitational force, some gravitational force it will be used in gravitational control. From coming to damping torque. Damping torque is nothing but to stop the pointer at final position as early as possible, as quickly as possible. That is called damping torque. This damping torque is given by these types: eddy current damping, air friction damping and fluid friction damping. Eddy current damping means it produces the voltage based on the Lenz's law, which is opposed the original produced EMF. Based on that principle, eddy current damping will be used. When the permanent magnets are used, where eddy current damping will be useful to measuring instruments. Next one, air friction damping. Air friction damping, air piston moves in the air chamber. The piston, when the closed chamber contains the closed chamber, when the force is applied on the piston moves in downwards. When remove the force, it will be goes upwards. So like piston movement in the air chamber give the air friction damping. And then fluid friction damping. Fluid friction damping means instead of air friction, so fluid will be used for the damping purpose to stop the pointer as quickly as possible. It consisting of a pot and filled with oil, iron vane or a spindle rotate on the against the rotation of the spindle. The force is developed. That force is called fluid friction damping. So PMMC, first one, the mainly important instruments are PMMC instrument and MI instruments. PMMC means permanent magnet moving coil instruments. So operate in the principle of force on a current carrying conductor in a magnetic field. It's consisting of a cylindrical coil, which is a rectangular coil. So which will be rotates on the between the magnetic poles. When the supply is given to the instrument, the torque will be developed. And it starts the rotation due to Faraday's law of electromagnetic induction. Based on that, aluminum coil will be rotated. vanes are connected. Okay. So two weights or springs are connected to this. Generally, this diagram belongs to gravity control. Otherwise, we are using spring also. Two spiral head springs instead of a balancing weight. So we are using spring control. Springs. Two opposite springs will be connected to the spring. One were used for the supply, and another one, when the supply is given to the instrument, it will give the deflection torque and move the coil. When the coil moves, spindle will be rotates. When the spindle rotates, pointer moves on a calibrated. It will it give the reading. So generally pointer attached to the coil. So here two springs are provided upper. Those springs are oppositely connected, which will give the controlling torque. So for pointer purpose we are using balancing weight. Pointer need to stable here. That's why balance weights are used. Advantage of and disadvantage of PMMC. High accuracy, low power consumption, uniform scale. Disadvantage means cannot measure AC directly and costly construction because springs are mostly cost, so it will be costly. So then we are going to next instrument, which is moving iron, MI instrument, moving iron instrument. So we operate based on magnetic effect of electric current. So MI instrument is used for an electric current. Okay, so MI instruments are used both AC and DC quantities, which can also used to measure the voltage and current also. So these instruments are economically and robust. So both chances are there. Either springs are used for controlling purpose or gravity control are also used in these MI instruments. This is the MI instrument. These instruments are classified again into two types: attraction type and repulsion type. This is attraction type. Attraction type measuring instrument is consisting of a iron vane. This is iron vane. Iron vane is attached to the spindle. Spindle contains the pointer and also it contains the piston. This piston moves up and downwards in the air chamber. When the pointer moves, when given the supply, the piston moves up and down based on that pointer rotation. The reading will be increased, piston moves inside. So when you are giving the supplies to the instrument, so pressure will be created inner side of the air chamber. So when pointer moves right side, piston moves inside. So the air will be pressurized and give the opposite reading to the pointer. Opposite torque to the pointer. It will stop at final position. So when the supply is given to the instrument, this is the coils. When we are giving to this coils, when supply given to these coils, the magnetic flux will be developed. This magnetic flux will be attracts the spindle. Due to attracts the, first of all, attracts the iron vane. When iron veins moves toward the coil, when iron vane moves toward the coil, spindle will be rotate. And iron moves, spindle will be rotate. When the spindle rotates, pointer moves on a calibrated scale. Okay, here air friction damping, due to the damping provided by the air friction damping. Controlling is provided by the gravity control. So for controlling purpose, balancing weight and controlling weights are provided. When the pointer moves, balancing weight always try to come backward. But due to deflection torque, pointer always try to move right side. But then it will be give the opposite torque by the balancing weight. So repulsion type instrument. Repulsion type instrument which consisting of a circular coil and which contains two iron vanes. One is fixed iron vane, another one is movable iron vane. So when the supply is given to the instrument, same polarity flux will be developed in the circular coil. This flux will be attracts the same polarity flux. Fixed vane and movable vane, both vanes, same polarity flux will be developed. Due to same polarity flux, repulsion force will be developed.